I am Dr. W. Gunale from Kamlanidhu Mahavidyalaya, Nagpur. Today we are going to discuss the hydrogen bonding in organic compounds. So, as we know what is hydrogen bond? Hydrogen bond is a weak bond and it is a form between hydrogen atom and the most electronegative element. Like nitrogen, phosphorus, fluorine, like that. And also we are going to discuss the what are the types of hydrogen bonding. One is a intermolecular hydrogen bond, second is the intramolecular hydrogen bond and their examples, and what is the effect of hydrogen bonding on the some physical properties like melting and boiling point, viscosity, and also the solubility of the compounds in the solvent. So all these properties and different aspect about the hydrogen bonding we are going to discuss in today's presentation. So today's topic is hydrogen bonding, and here we are going to discuss the what is hydrogen bond in the organic compounds and also the different types of hydrogen bonding. As we know, hydrogen atom is covalently bonded, and therefore here in case of hydrogen bonding, whenever the molecule contains hydrogen atom linked to the highly electronegative atom like fluorine, oxygen, nitrogen, this atom attract the shared pair of electron more, and so this end of the molecule become slightly negative, and while other end is becomes slightly positive. The negative end of one molecule attract the positive end of the other, and as a result of this electrostatic attraction, a weak bond is formed between them. This bond is called hydrogen bond. It is represented by the dotted line as shown here, and so in short we can say that hydrogen bond is formed between hydrogen atom and most electronegative element like nitrogen, fluorine, oxygen, and there is a formation of weak bond. This weak bond is known as the hydrogen bond, and this hydrogen bond is shown by the dotted line here in this way, and covalent bond generally shown by the solid line. So here this is the solid line is the covalent bond HX, this is one molecule, and this is another HX, another molecule. So this is the hydrogen atom of one molecule, electronegative element of other molecule, forming this dash dash is the hydrogen bond. In this way the bond is formed between these two atom. One is a hydrogen and second is a electronegative element. So X is the electronegative element here, and therefore they have negative charge and hydrogen have positive charge. So this is the hydrogen bond, and this hydrogen bond generally there are some certain conditions also for this and the strength of hydrogen bond. So we can say that here because of this hydrogen bonding, hydrogen atom linked to two electronegative atom, and one by one covalent bond and the other by hydrogen bond. Hence it is said to form the hydrogen bridge, and we can say that now there are certain conditions for the formation of hydrogen bonding. In the formation of hydrogen bond, the conditions are the molecule must contain highly electronegative atom linked to the hydrogen atom, and second is the size of electronegative atom should be small. Therefore only the fluorine, oxygen, nitrogen atom can form hydrogen bond, as these atoms are small in size and have high electronegativities. Chlorine having the same electronegativity as that of the nitrogen but does not form hydrogen bond due to its larger in size. So these are some conditions for the formation of hydrogen bond. And what is the strength of the hydrogen bond? Then we can say that in case of strength of hydrogen bond, the hydrogen bond is very weak bond, and the strength of hydrogen bond is intermediate between weak van der Waals forces and the strong covalent bonds. Therefore here the bond dissociation energy for the covalent bond is between the 209 to 418 kilojoule per mole. That for hydrogen bond is only 12.6 to 41.8 kilojoule per mole. The dissociation energy of the hydrogen bond depends upon attraction of the shared pair of electron, and therefore hence on the electronegativity of the atom. The bond energy in case of these elements are shown like here. The bond dissociation energy for HF bond is 41.8 kilojoule per mole. For hydrogen oxygen HO bond dissociation energy 29 kilojoule per mole, and nitrogen hydrogen bond dissociation energy 12.6 kilojoule per mole. So different strength is there, and it is intermediate between van der Waals and the covalent bonds. So now after this, now there are two important types of hydrogen bonding, and these two important hydrogen bondings have been shown here. And first is the intermolecular hydrogen bonding. As we know, inter means between the two molecules. So molecular, intermolecular hydrogen bonding. When hydrogen bonding take place, and in this case, between the different molecule of the same or different compound, it is called intermolecular hydrogen bonding. Or in short, we can say that intermolecular hydrogen bonding, in case of this hydrogen bond that exists between the atom of two or more molecule of the same substance, is known as the intermolecular hydrogen bond. And such type of bonding affect the properties of the compound. And so this is called intermolecular hydrogen bonding. And examples are here in case of intermolecular hydrogen bonding. So very simple, we can explain. Because of this intermolecular hydrogen bonding, there is an association of the large number of molecules because of this intermolecular hydrogen bonding. And examples are hydrogen fluoride, water, ammonia, alcohol are the examples of intermolecular hydrogen bonding. And therefore here, because of the formation of intermolecular hydrogen bond between the similar molecules, there is a large number of molecules associated together, as shown some examples also here. So it is the bond, intermolecular hydrogen bonding means it is the bond formed between hydrogen atom of one molecule and electronegative atom of other molecule. So there is an association of the molecules. So first example is shown here, hydrogen fluoride. And in case of hydrogen fluoride, we can say that fluorine is the highest electronegative element and the value of electronegativity is 4, and it forms strongest hydrogen bond. Hydrogen fluoride exists in a see the structure. So this is the HF, hydrogen of one molecule, electron, and this is another HF. So this is the intermolecular hydrogen bond. Fluorine is the electronegative hydrogen. So in this way, see the alternate covalent bond, hydrogen bond, covalent hydrogen. So in this way, hydrogen atom of one molecule and form a bond with the electronegativity of other molecules. So this is known as a this is the hydrogen bond, which is shown by dash dash line. And another example is the water. And in case of water, they also form the bond between the hydrogen atom of one molecule. This is the H2O. This is another H2O, hydrogen, and this oxygen, hydrogen of one molecule, oxygen of other molecule, forming this type of bond. And in case of water, highly electronegative oxygen atom is linked to the hydrogen atom. Because of higher electronegativity, oxygen atom attract the electron of the OH bond towards itself, and because of this, oxygen carry partial negative charge and hydrogen atom have partial positive charge, and the negative end of the molecule attract the positive end of the other molecule and forming the hydrogen bond shown, which is shown here. So this is the negative end of one molecule and positive end of other, and forming this type of intermolecular hydrogen bonding. So this is second example. And third example is the ammonia, and similarly here ammonia also forms the hydrogen bond. So this is NH3, and this is forming with the this electronegative, and this is the positive and H plus hydrogen. So this is one molecule, this is second, and forming the intermolecular hydrogen bonding in case of ammonia. In case of ammonia, nitrogen is the electronegative element, and so in ammonia molecule, the electronegative nitrogen atom is linked to the hydrogen atom. Therefore, hydrogen bonding take place in this molecule is shown here in this slide. Fourth example is alcohol, that is the formula is ROH or RCOH. These molecules contain the highly electronegative oxygen atom and linked to the hydrogen atom, and therefore undergo hydrogen bonding, which is shown here. So this is alcohol, R and carboxylic acid. So this is the ROH second molecule, oxygen and hydrogen forming this bond. Similarly, in this way, there is association of the molecule. This is the RCOOH, and this is RCOOH forming this is the hydrogen bond in case of carboxylic acid. So these are the examples of the intermolecular hydrogen bonding. And the second type is the intramolecular hydrogen bonding. As we know, intra means within the molecule. So here hydrogen bonding which take place within the molecule itself is known as the intramolecular hydrogen bonding. And because of this formation of intramolecular hydrogen bonding, there is a chelation, means formation of ring. So we can say that the hydrogen bond that exists between the two atoms of the same molecule is known as intramolecular hydrogen bond. It is also known as internal hydrogen bonding. Such type of bonding is possible only if the hydrogen and more electronegative atom are present in the same molecule. It results in the cyclization of the molecule. It has negligible effect on the properties of the compound. Compound having electron withdrawing groups and hydrogen atom near each other show such bonding. Some examples are shown, that is the salicylaldehyde, orthonitrophenol, chlorophenol. These are the examples here shown. So number of examples are there, and so again I am repeating that intramolecular hydrogen bonding means the intra means within the molecule. So it is a bond formed between the hydrogen atom and electronegative element of the same compound or same molecule. So within the molecule there is a formation of hydrogen bond. That bond is known as intramolecular hydrogen bonding. So some examples are shown here for this, and because of this it is also known as chelation. Chelation means formation of chelate ring, that is the formation of ring. So in case of chelate, as we know in the complex, simple complex and chelate complex are more stable, and chelate means the formation of ring. Chelate word come from the chela and like that. So here is the formation of, because of the formation of intramolecular hydrogen bonding, there is a formation of ring. So see the one example. One is the orthochlorophenol. So this is the these two groups are on the ortho position. This is ClOH. So there is a formation of bond between hydrogen and chlorine, electronegative. So this is the hydrogen bond, and because of this formation of hydrogen bond, this is the formation of ring structure. Therefore it is known as chelation, and this type of bond is formed within the molecule in the same compound or same molecule. So this is called intramolecular hydrogen bonding. Another example is nitrophenol, orthonitrophenol, NO2 and OH. So here is a bond. In case other example, salicylic acid having OH and COH. So here is the formation of between the bond between hydrogen and oxygen. 2,6-dihydroxybenzoic acid. So here this is the COOH, and here dihydroxy. This is one OH, this is one OH, and this is COOH. So this is these two OH and COH. So here is a formation of bond, here is also formation of bond. So in this way, this intramolecular hydrogen bond is formed within the molecule. So there are two types of hydrogen bonding. One is a intermolecular and second is a intramolecular hydrogen bonding in the organic compound take place. So here, and next is what are the effects of this hydrogen bonding on the physical properties, and three properties we are going to discuss. One is a melting point and boiling point, and second is a solubility of the compound, and third is a viscosity of that compound. So what is the effect? So we can say that hydrogen bonding greatly affect the physical properties of the substances, and as properties as melting point, boiling point, solubilities in the water, stability, viscosity, and these are some properties. So first property is the melting and boiling point, and in case of, as we know, the melting point and boiling point of the substances largely depends upon the type of hydrogen bonding they undergo, and in case of in this case, in general we can say that intermolecular hydrogen bonding, due to association of molecule, such molecules have high melting and boiling point. Some important examples shown here. So patients of intermolecular hydrogen bonding in the compound, they have higher melting and boiling point generally, because large amount of energy required to melt or to boil the solution. So in this way, so we are taking some example. An important example is the water, and in case of water, among the in case of water example, in case of hydrides of group number 16 of the periodic table, water has lowest molecular mass but still has highest melting point, the boiling point, and water is a liquid at room temperature, while all other hydrides like H2S, H2SE, H2TE of this group are gases. Shown here some examples here. This is the table shows melting and boiling point of the hydrides of group number 16. So in this case, the molecular mass is shown. Water is 18. H2S, this is the molecular weight increases, and melting point of water is 273, and other having less. So this is water is having high. Boiling point of water is also more, and as compared to other. So shown here the comparison. These are the hydrides of this group number 16. Hydrides of oxygen, this sulfur, selenium, tellurium. So these are the why now here the question is there, why water is in a liquid and other hydrides, that is H2S or H2SE, are the liquids are these compounds are gases. So why? What is the reason? So we can explain on the basis of hydrogen bonding. And as we know, in water, hydrogen atoms are linked to the highly electronegative oxygen atom and hence undergo intermolecular hydrogen bonding, and this intermolecular hydrogen bonding is shown here in this way. This is H2O, another H2O, so this is undergo hydrogen bonding and exists as an associated liquid. So because of this water, and in case of the sulfur and other element of this group are not only less electronegative than oxygen but are also bigger in size than oxygen, and because of this H2S, H2Se, H2Te do not form hydrogen bond, hence exists as a discrete molecule. Therefore, in order to boil water, in addition to the addition to energy required for vaporization, a large amount of energy needed to break these hydrogen bond. On the other hand, since H2S does not form hydrogen bond, therefore no additional amount of energy is required. This is important reason. In other words, the energy required to boil water is greater than that of H2S. In fact, energy required to boil H2S is so small that it is easily melt by the collision of the molecule at room temperature, and H2S exists as a gas at ordinary temperature. On the other hand, energy needed to boil water is so large that it cannot be provided by the collision of the molecule at room temperature, and because of that, water exists as a liquid at ordinary temperature. So H2S, water, here important, water is a liquid at room temperature, while other hydrides, that is H2S, of this group are gases. So we can explain this is on the basis of hydrogen bonding, and so the question can be asked here, water is a liquid and H2S is a gas. Why? So we can explain this here. Second important example here is a hydrogen fluoride. So in case of hydrogen fluoride, also fluoride hydrides are shown here, boiling point and group number 17. So these are the compounds, fluorine, chlorine, bromine, iodine. Molecular mass is given, and this is having lower molecular mass. Melting point is shown, and boiling point is also shown here. So now in this case of hydrogen fluoride, like water, it also has highest melting point and boiling point among the hydrides of group number 16. In the similar way now, hydrides of group number 17, hydrogen fluoride has lowest molecular mass but still is a liquid and has the highest boiling point, which is shown. Boiling point is a highest boiling point. The abnormally high boiling point of HF is due to the fact that fluorine has the highest electronegativity and much smaller size. Hence it forms a much stronger intermolecular hydrogen bond. Consequently, we can say that HF exists as a associated molecule. So because of intermolecular hydrogen bonding, and on the other hand, chlorine is not only less electronegative but is also bigger in size than fluorine, and hence it forms only much weaker hydrogen bond. The other element of this group do not form hydrogen bond at all. So this is the reason that this is another example of intermolecular hydrogen bonding and properties of melting and boiling point. And third example is alcohol, and here also we show the comparison of boiling point and alcohol and ether and thioalcohols. So here these are some compound. Boiling point of these three compounds are shown. Alcohol, this is alcohol. See now here boiling point of alcohol, methyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol. So it is increases, and here boiling point of thioalcohols shown here, and boiling point of ethers also shown here. So different type of ether and alcohol and the thioalcohol. So we can also compare. So in case of alcohol, ether and thioalcohols, the boiling point of alcohol are much higher than those of the corresponding thioalcohol. See now, the boiling point of first column alcohol are greater as compared to the thioalcohols, and also ether shown in the table. The higher boiling point of alcohol than those of corresponding thioalcohol is due to the intermolecular hydrogen bonding, which leads to the association of alcohol molecules. Because of there is a intermolecular hydrogen bonding in the alcohol, they show higher melting and boiling point. In the thioalcohols, we can say that thioalcohols exist as a discrete molecule. Since they do not form hydrogen bond due to lower electronegativity and bigger size, of sulfur and hence have lower boiling point as compared to the alcohol. So depending upon the formation of intermolecular hydrogen bonding, alcohol have higher boiling point as compared to the thialcohol, and thialcohol do not form hydrogen bond. So we can say that those are the compound which are forming the hydrogen bond have higher melting and boiling point as compared to the compound which is not having ability to form which is not forming the hydrogen bond. In case of ether, ethers are isomeric with the alcohol, but their boiling point are much lower than those of the alcohol. This is due to the reason that, unlike alcohol, ethers do not form hydrogen bond. As a result, ethers do not undergo molecular association and hence have lower boiling point than the corresponding alcohol. Similarly, we can also explain that the boiling point of dihydric, trihydric, polyhydric alcohol are much higher than those of corresponding ether. So, these are the reasons that alcohol show higher boiling point. And so this is the first, what is the effect on the melting and boiling point, and second is the solubility in the water. So in case of solubility, we can say that solubility of these substances in the water and compound which can form intermolecular hydrogen bond with the solvent like water would form generally soluble in that solvent, but compound in which hydrogen bonding with the solvent molecule is prevented due to intramolecular hydrogen bonding would be less soluble or insoluble in that solvent. So we can say that the compound which form hydrogen bonding with the solvent are soluble, and which do not form hydrogen bond are insoluble. And some examples are also there. Hydroxy compound like methyl alcohol, ethyl alcohol, sugar are highly soluble in water due to the formation of hydrogen bond between the solute and water molecule. So some examples are also shown here. This is the water, and this forming here example is shown, that is this is water and this is alcohol forming a hydrogen bond. Therefore alcohols are soluble in water. And other examples also we can show with here, that orthonitrophenol is another example. This is solubility. These are the examples shown here. Hydroxy compounds, that is water and alcohol soluble in the water. And the second example is orthonitrophenol, in which OH group is not available to form the hydrogen bond with the water, and due to chelation is less soluble in water than non-chelate isomer paranitrophenol. So this is one example of paranitrophenol forming the hydrogen bonding but less insoluble because of this chelation, and therefore it cannot form the bond with the hydrogen bonding with the water solvent, and therefore these compounds are less soluble or is insoluble or slightly less soluble. And so these are some examples of solubility, and which we can say that in short solubility about the substance in the water. So those are forming the hydrogen bonding with the water solvent, then it is soluble. And so here is shown example, and in this case orthonitrophenol is unable to form the hydrogen bond with the water solvent, therefore it is less soluble in the water. So these are some examples. Second, hydrogen bonding also affect the solubilities. And third property is there, that is the viscosity. And as we know that with the increase of intermolecular hydrogen bonding, the association of molecule increases, and therefore the flow of molecule is restricted. The resistance to the flow of liquid is known as the viscosity. And as we know, glycerol is more viscous than glycol, which is more viscous than ethanol. Ethanol has one hydroxyl group per molecule, whereas glycol has two hydroxyl group per molecule, and whereas glycerol has 3 hydroxyl group per molecule. Therefore, extent of hydrogen bonding between the various glycerol molecules is much more than the ethanol molecules. The greater the extent of hydrogen bonding, make glycerol a viscous liquid. So, glycerol is more viscous than glycol, glycol is more viscous than ethanol. So, this is one example is shown here in case of viscosity. So, compound which form the hydrogen bond are more viscous, and compound which do not form hydrogen bond are less viscous or no viscosity. So viscosity also affected by the presence of hydrogen bonding. So we can say that hydrogen bonding affect this property, physical property, viscosity. So there are 3 properties: melting point, boiling point, solubility in water, and viscosity. All these 3 physical properties are affected by the presence of hydrogen bonding as compared to the compound which do not form hydrogen bonding. So here we have completed this part of hydrogen bonding, and here we have discussed the what is hydrogen bond, what are the examples of hydrogen bonding, types of hydrogen bonding, example of types of hydrogen bonding, and the effect of hydrogen bonding on the properties of the compounds.